So today we are going to be learning about Brownian motion. Okay, but before that, let me ask you a question. Alright. So, have you ever had this experience before? You are in this super dark room. Alright. This extremely dark room. And then you start to shine a torch. Alright, you're gonna take out a torch. You're gonna shine the torch in the room. Okay. Now of course, the first thing that you'll be noticing is, well, there's light, right? You can see everything. It's brilliant. Okay, but have you ever noticed something when you shine a torch in a bright room? Have you ever actually looked at it? Actually wondered, actually pondered on there's something that's going on? And some of you may not even know what I'm talking about, and that's fine. I'll explain what I'm trying to talk about after I finish this little drawing of this. Whoa. Okay. So, now, I'm pretty sure that y'all have noticed that when you shine a torch in a dark room, you always see these small little particles floating around in a torch, right? You always see these small little things just like, moving randomly, and they are not just staying there in the air, stationary. They're literally moving randomly and continuously super fast. And you're like, what in the world is going on, right? You may not actually know what's going on, but something's going on. What is going on? So, today we'll break down what causes this. And what actually causes this is something super interesting called Brownian motion. Okay, Brownian motion is not spelled like this. I don't know how you spell it, okay, but no, it's like this. Brownian motion. Okay, you pronounce it Brownian motion or Brownian motion. Last time I also pronounced it as Brownian motion, I got it wrong, alright? It's not Brownian motion, it's Brownian motion. Okay. So what exactly is Brownian motion? Why does it cause these particles to be floating around when you shine a torch? Let's dive into the world of Brownian motion. Okay, so firstly you must understand the kinetic particle model. And basically, you must know this. Now, I've actually gone through this in the kinetic particle model lesson, but we will revisit it one more time. Okay, now you may be like, what am I even drawing, right? Am I just drawing something for fun? Then what am I drawing? What's this? Sunny side ups? No. Okay, so this is solid. Okay? Now let's draw separate one. This represents a liquid. Okay. Now, last one. Look, something like this. This represents gaseous. Now, if you have like completely no prior knowledge on this, you'll be like, what am I even drawing? Am I just drawing this for fun? Am I just trying to tease you? No, there's actually a meaning to this. Now, these small little thingies represent the particles in a solid. Now, solid particles are arranged in a super packed manner, which is why they have a fixed shape and fixed volume, because you can see it's all so densely packed, and that's why they're dense. Make sense? So you can see they're all, so they're sticking together, and they're held by these strong intermolecular forces, which I'll represent with this black pen. So you can see that they're held by these strong intermolecular forces. They're super strong. They're holding them together like a couple. Now, liquids. These are also the particles in the liquid. But you can see over here, they are definitely a bit weaker. You can see that these particles are a bit further apart, right? And you can see that the intermolecular forces are just moderately strong. Okay? They're not that strong this time. Okay, now, for gaseous state, you can really see that there's an entire gap here, gap here, gap here, gap here, right? You can see the distance between them is so far apart, and there's like very weak intermolecular forces that's like connecting them. So you can see the big difference between solid, liquid, and gaseous. It's actually a very big difference. Okay, so how is this related to Brownian motion? Okay, now not only do they like be arranged this way, but movement wise that's also something. Okay, so solids, you can clearly see that they are neatly packed and they literally cannot move. They cannot move freely. They are all just like fixed in place. Okay, so I'll write it down for you. Cannot move. Fixed in place. Okay, for liquids though, you can see that they are a bit further apart, right? They're not that far apart whatsoever. So they can sort of move a bit. They rotate and slide past each other. Okay? Now, lastly, for gaseous state, it's like almost so far apart. You can see the entire gap over here. Okay? So they can literally move freely and rapidly. And this motion is continuous. It's random. Okay? So, talking about movement, solid cannot move. They're literally just like vibrating a bit only. Liquids, they have sort of like the luxury to move a bit, but they rotate and slide past one another, so it's not that much. I'm gonna give you something to draw this, and you really visualize. Let us see this picture in your head. Okay, now, gaseous state. They have the luxury to move anywhere they want in this universe. They can really like completely just move anywhere they want. So this is gaseous. Now, knowing this, how is this related to the torch thing? Okay, now, I'm going to explain what's going on behind the scenes so that you can understand. Now, basically what's going on, right, is that firstly, we must understand that there's dust in the air. Okay, so I'm going to represent the dust with this black thing. Okay, dust. There's dust in the air. So these are dust particles in the air. Now I can't see them because they're so small. Okay, it's a dark room anyway. Can't see them. Yeah, you light up your torch, you just pretty much can't see them. But here's the thing, you see them moving. Why? Now, there is actually gas particles in the air. Agree. This, and literally, if you look around you, you're probably in a room or something, right? But no matter where you are, there's definitely gas particles all around you because it's air. There's air around you. Agree? So there's gas particles all around you. So over here, surrounding these dust particles are some gas particles. And remember what we learned about the movement of gas particles? They move quickly, they move rapidly and randomly in continuous motions. So now you can sort of see, after I've put 2 and 2 together for you, why these dust particles will move around randomly. Because of the gas particles. Now, the gas particles don't look like this, right? They are actually moving, okay? But I can't animate things for you, okay? But you can just try to picture these gas particles just boing, 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 just moving around randomly anywhere they want. And let me show you. Let's just close in on one single one. Let's close in on this one. The gas particle says, today I'm gonna move to over here. Because remember, it's random. It can choose to move over here, but it doesn't want to. It wants to move over here. So it's gonna go up. Boom! They are gonna collide. Alright? And once they collide, you agree that this dust particle will be like pushed over there. It'll be like boom! Massive explosion. So this is actually what's going on behind the scenes. Alright, where you just see, you don't see these blue things, you just see the black things, and you just see them just moving around like sparks. But they don't move because they're alive. They don't move because they want to move, because they are like supposed to be moving. It's because of the gas particles that bombard them. So let's dive into one more again. Alright, let's see dust particle. Now remember, dust particles move. These gas particles move randomly, like actually randomly. They can choose to move here. They can choose to move here. They can choose to move here. And continuously. That means they will just boom, boing, 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 like balls ricocheting. But then let's say this gas particle is like, alright, I'm gonna move here. Right, hit. Boom. This one is gonna push it. And then that's gonna move that. And let's say this dust particle moves here. And suddenly, it meets this other gas particle, which is like, alright, I'm gonna push you back. And it's gonna boing, 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 boing. You can see the action going on, right? It's actually kind of fun. So that is literally why this is basically called Brownian motion. Brownian motion. And I want you guys to copy down the definition. Brownian motion is the continuous and random motion of solid particles in fluids, liquids, and gases. I'd be shocked by this word, liquids. Yes! Brownian motion can also happen in liquids. Now, just now the one I showed you was in gases, but this actually also works in liquids. And I'll give you a very historical example of Brownian motion in liquids. Let's go. So now, actually, Brownian motion was discovered by this guy, okay? This scientist, right? And this scientist is called Robert Brown. Alright, Brownian motion discovered by Robert Brown in 1827. I'll be like, how? Why? Okay, now, this Robert Brown guy was like, alright, I am just going to observe through a microscope some pollen grains. So he took a beaker, filled with water, right? And then he went ahead to just take some pollen grains and just throw them inside. And he started observing these pollen grains through a little microscope. Okay. And guess what? These pollen grains were moving. Now, at the start, it was like, these pollen grains are alive or what, right? You may think, oh, the pollen grains, like plants, right? They're living things, right? So they're like, life, right? Yes, that's true, but was this a real reason? Was it why the pollen grains were moving? No. So then after that, after Robert Brown, right? In 1905, there was another scientist. Not exactly a scientist. And there's none other than the Albert Einstein. Oh, sorry. It's glitching. My pen is glitching. My stylus. L. What? Okay, but you get my point, right? Like, don't tell me you don't know how to spell Albert Einstein. 1905. This is Albert Einstein. Robert Brown, you're dumb. Okay, he didn't really say that, but I made it up myself. Robert Brown, I found the reason. Right, this is Albert Einstein talking. Robert Brown, I found the reason why your little pollen grains over there were moving. And Robert Brown's like, what? What the hell? Why? Okay, but Robert Brown didn't really respond whatsoever. And I said, it's because of this thing called Brownian motion. And I was like, what? Okay, so Albert Einstein explained the phenomenon. And let me explain for you. I'm Albert Einstein, right? Listen to me. Okay, so what's going on? The liquid particles. Now, you see, gas particles, they move very fast. Liquid particles, they don't move as fast, but they still move, alright? You still agree on that. They still rotate a bit. So, what happens is that these pollen grains, same like the gas with the dust. These liquid particles, alright? The liquid particle, and the liquid particle, and the liquid particle, and the liquid particle, liquid particle. Right? I'm like, okay, hello, little liquid particle. I'm gonna start moving randomly. I'm like, boom! And then this thing's like, oh, what the shit? I propel over there, right? And then this guy's like, hey, why are you coming over here? Boom! And then it pushes back, right? And then this guy's like, oh, okay. And it's like, right, fine. It's pushed over. Sorry, wrong pen color. Gets pushed over here. Okay. And then maybe there was like another one over here, and then boom, ba, boom, ba, boom, ba. You get my point? So that's exactly what happened. So this was actually Brownian motion. And now, till now, right? The particles, like gas particles, solid particles, liquid particles, gas particles. Under a microscope, you may think under a microscope, we can actually observe these particles, but we actually can't. Even microscopes cannot see these particles. And that's literally how small these particles are. Even the microscope can't see it. That's how small the particles are. So, so then here's the problem, right? Many scientists come up with the theory of, hey, they are particles. But the problem is, because we can't really observe it under a microscope, a lot of scientists start to doubt it. It's like, is what you're saying actually true? Right? They start to doubt it. Like, are you really, saying the truth? Is there really particles? Because they can't observe anything under the microscope because it is too small. Particles are too small for them to observe under the microscope. So these scientists are like, are you like, what are you saying, right? But here's the thing. Thanks to Brownian motion, thanks to Albert Einstein, thanks to Robert Brown, they did an experiment and we can see the pollen moving. And clearly, we can infer it's because of the liquid particles that bombard it, collide with it, that cause these collisions with the unseen particles, the unseen water molecules. And that's why we can prove that, hey, there are actually these particles, because these particles are the stuff that push the pollen grains over. Boom. Sorry, wrong color. Boom. Bam. Right. And the similar can be done with the torch stick. You can see the dust particles. So that's why it's proven, officially proven, that there are these particles, right? Because of these collisions in Brownian motion. So that's actually the reason why. Okay? So that's all. Oh, sorry. I was under a panic. Okay. So that is literally all about Brownian motion. Alright? I hope you guys like it. I hope you guys learn a thing or two about firstly these two dudes. And more importantly, just Brownian motion, what in the world it is. Because now, next time, when you're in a dark room, right, and you shine this torchlight, right, and your mom's like, hey, why are these little things just moving around? Oh, they're insects, right? And then you can start being the nerd and telling them, oh, actually, it's because of this thing called Brownian motion, blah, blah, blah. So thank you very much for you guys watching. I don't know what to say. Like and subscribe, whatever. Okay, you get my point. Okay, so peace.